Okay, so first of all, to solve this equation, we need to go through with the formula, which is F equals to G times M1 times M2 divided by D squared, which is the distance. So first of all, we need to count in the variables we have. So first of all, G will always be the same in every equation that uses this formula and has G. It'll always be 7 times 10 to the power of negative 11. Next we have M1, which is from this problem, it is 6 times 10 to the power of 24. Then next we have M2, which is 2 times 10 to the power of 30. The last one is that we have D. D is 1.5 times 10 to the power of 11. Okay, so next to solve this problem, we need to put in the variables we have into the equation. So we can say that F is equals to G. I'll use brackets to make it easier to differentiate. So first of all, F is equals to G, which is 7 times 10 to the power of negative 11 times 6 times 10 to the power of 24 and times 2 times 10 to the power of 30 divided by 1.5 times 10 to the power of 11 squared. Okay, so next is that we need to multiply these, we need to go forward with the equation. So the first step is to, let's ignore all the tens of the exponents. Let's ignore it first, and let's ignore the bottom part first. Let's go with the top part first. Okay, so first of all, we need to find out the sum of 7 times 6 times 2. 7 times 6 is, hold on, let me calculate it. 7 times 6 is 42, and 42 times 2 is 84. And so the total is that we can say that only for the top, okay, 84 is the sum of this, and this. And then now we need to count the tens, but keep in mind for now this is only the top, okay? We're not in the bottom yet. Okay, so first of all, if it's hard for you, then just count the positive ones first, so that you don't have to handle like negative numbers at the front. So first of all, let's just add up these exponents. 24 plus 30 is 54, and 54 minus 11 is 43, which makes it 84 times 10 to the power of 43. And so now we're going here at the bottom. Okay, for this one, we just need to square up this value, and we don't need to square up the 10, but we need to change the exponent. First of all, let's focus on this. So 1.5 squared is 2.25 times 10 to the power of, for the exponent, when we have a bracket like this, we need to multiply the exponent inside of the exponent outside. So in this case, it's 10 to the power of 22. And so now we can just continue the equation as usual, which is F equals to 84 divided by 2.25 is 37.3333, so on, and 10. Now if it's division, we just need to minus the exponents, which is, sorry, I'm really bad at minus 22, which is 10 to the power of 21. But since scientific notations, the ones that are like times 10 to the power of anything, you can't, it cannot be over 9.99 or whatever. It has to be below 10. So now we'll just we need to move the decimal point to here, so it makes it 3.73 times 10 to the power of, hold on. So now if we move the decimal point here, it becomes 3.73 times 10 to the power of 22. The reason why this one adds is because we moved a decimal point. The 10, it makes us like easier to count, so that we don't have a lot of zeros at the back, and we're basically just adding another zero as if like it's a decimal point. That's why we add another number to this, and this becomes 22. So the final answer is 3.73 times 10 to the power of 22.